The evolution of electrical grounding. Grounding is a principle of electricity that sometimes puzzles homeowners. To understand its importance to a home wiring system, it is important to know something about the nature of electrical energy flow. What is electrical grounding? Grounding offers excess electricity, the most effective and safest route from an appliance back to the ground by way of an electrical panel. Electrical grounding is a backup pathway that is generally only used if there is a fault in the wiring system. Electrical service to North American homes began in the late 1890s and blossomed from 1920 to 1935, by which time 70% of homes were connected to the electrical utility grid. In the following 200 years, the methods for installing wiring in those homes has seen several important innovations aimed at improving the safety of electrical systems. Between 1890 and 1910, a wiring system known as knob and tube was the principal system of installation. It was quite a dependable system for the time, and a surprising number of homes still have knob and tube wiring functioning, where it is often found alongside more modern updates. In the 1920s to 1940s, electrical installations took a turn to a more protective wiring scheme. Flexible armored cable, or flex, also known as greenfield, was a welcomed addition to home wiring because the flexible metal jacket helped to protect the wires from damage, and also offered a metal pathway that could ground the system when properly installed. In the 1930s, a quicker installation method was developed. Non-metallic sheathed cable was born, which incorporated a rubberized fabric coating sheath, much like knob and tube wiring, but here the hot and neutral wire were run together in this one sheathing. It also had its drawbacks due to the lack of a ground wire, but its development would eventually lead to major innovations. Early sheathed cable, however, also has an expected lifespan of about 25 years, and where it is still in use, such installations need to be upgraded. The 1940s brought the age of metal conduit. This invention allowed users to pull many individual conducting wires in the same rigid metal tube enclosure. The conduit itself is considered a viable grounding method, and the system can also allow another separate grounding wire, usually a green insulated wire, to be pulled through the conduit. Conduit has been in use ever since those days and is still the recommended method for wiring in certain applications, such as when wiring needs to be run along the face of basement masonry walls, or in exposed locations. Most homes have some areas where conduit is used, though it is now sometimes made with rigid plastic PVC conduit rather than metal. The newest addition to wiring was introduced in around 1965. This form of NMD cable was an update to older NM cable, incorporating the use of a bare copper grounding wire that joined the insulated hot and neutral wires contained within the sheathing. Instead of rubberized sheathing, modern NMD cable uses a very tough and durable vinyl sheathing. This update made the cable inexpensive and very easy to install. It is a very flexible product, and is used extensively in virtually every new home built. Along with NMD cable for interior use, a related type of cable was also developed for underground use. Underground feeder wire, UF, can be buried directly under the ground without the need for a protecting conduit. This type of wire has a hot, a neutral, and a ground wire embedded in a solid plastic vinyl sheath that protects it from moisture. This offers an inexpensive method for running power underground to outbuildings and yard lights. Through most of the history of residential electrical service, the preferred metal used in the conducting wires has been copper, known as the best conductor of electrical current. In the mid-1960s, when copper prices were quite high, aluminum came into vogue as a material for electrical wiring. Residential installations between 1965 and 1974 sometimes used wires that were solid aluminum, or aluminum covered with a thin layer of copper. Aluminum or copper-coated aluminum wiring is perfectly safe if connected to receptacles, switches, and other devices rated for use with aluminum, but it can pose problems when it's installed with devices intended for use with copper wiring only. To prevent electrical danger, your home's electrical system includes a backup plan, a system of grounding wires that runs parallel to the hot and neutral wires. It provides an alternate pathway for electrical current to follow should there be a breakdown in the system of hot and neutral wires that normally carry the current. If a wire connection becomes loose, for example, or a rodent gnaws through a wire, the grounding system channels the stray current back to ground by this alternate pathway, tripping the breaker, before it can cause a fire or shock. The grounding pathway is generally formed by a system of bare copper wires that connect to every device and every metal electrical box in your home. In standard sheathed NM cable, this bare copper wire is included along with the insulated conducting wires inside the cable. The bare copper grounding wires terminate in a grounding bar in your main service panel, and that grounding bar is in turn connected to a grounding rod driven deep into the earth outside your home. This grounding system provides a path of least resistance for electricity to follow back to ground, should a break in the wiring system allow electricity to leak out of the preferred system of black and white circuit wires. In most home wiring systems, evidence of the grounding system can be seen at each outlet receptacle, where the third round slot in the face of the receptacle represents the grounding connection. When a grounded appliance plugs into such a receptacle, its round grounding prong is now directly connected to the system of bare copper grounding wires inside the house circuits. Not all homes have this elaborate and complete grounding system formed by a network of bare copper wires. While such a grounding system is standard in homes with circuit breakers that are wired with sheathed NM cable, older wiring systems installed before 1965 may be grounded through metal conduit or metal cable, not bare copper grounding wires. And even older systems installed before 1940 may not have any form of grounding at all. Such is the case in knob and tube wiring, where there is no grounding path of any kind. Many older systems have already been updated, and it is a good idea to have it done if your wiring is of this older generation. One clue that your wiring is old is when the outlet receptacles have 2 slots rather than 3. This indicates the outlets may not be grounded. A pretty typical diagram for the grounding system for a house is shown here, along with a few of the current carrying conductors commonly called live and neutral. On the far left is the transformer outside the house. And on the far right is an appliance that's plugged in. In between them is a breaker panel and a wall socket of the style found in North America. The green dashed line shows the normal path for current to flow. Notice the grounding electrodes for making an electrical connection with the earth ground. To use the U.S. National Electrical Code, NEC, as an example, Article 250.52 lists 8 types of grounding electrodes. One very good type is an electrode encased in concrete, such as the cold water supply, since concrete continues to draw moisture from the ground, and makes good physical contact due to its weight. You have to be careful of using metal water pipes that seemingly go into the ground, as sections of these are often replaced with non-metallic pipes during regular maintenance. Another is a grounding rod or pipe at least 8 feet long and inserted deep enough into the ground. By deep enough, we mean to include factors such as the fact that the frost line doesn't count as a good ground, since it has a high resistance. Notice also in the diagram that there are places where the various metal cases are connected to the grounding system. This is called bonding. Now, how does all this system grounding help us? Let's start with handling a fault. One purpose of the grounding system is to cause a breaker in the breaker panel to trip if there's a short circuit, hot shorted to ground, as indicated by the fault at number 1 on the slide. That happens if there's an appliance with a metal case and the insulation on the live wire in the appliance is damaged, causing the copper wire inside to touch the metal case. The case becomes an extension of that live wire. This is called a fault. But the metal case is connected to an electrical path consisting of the ground wire and the power cord plugged into the wall socket, as well as the wire from the wall socket to the breaker panel. These are referred to as the equipment grounding conductors. In North America at least, in the box where the service first enters the house, the equipment grounding conductors are connected, or bonded to the neutral wire. In this case that box is the main breaker panel. In most breaker panels this connection is made by having both the wires go to metal bars that are screwed, or bonded, to the panel's case, thereby making the electrical connection through the case. Following the red dashed line from the fault, a high current now runs through the live wire, through the appliance's case, and uses the equipment grounding wires as the return path to the breaker panel. From there the current goes through the panel's case to the neutral bar and neutral wire back to the transformer. Along the way, The live wire runs through a breaker, as indicated by number 2 in the breaker panel, and the current is high enough to trip that, opening the circuit and making it safe again. But where does the earth ground come into it? Often it doesn't. Sometimes, however, as shown by the blue dashed line, a little current will flow through a parallel path including the grounding electrodes and the earth ground.